Hello students, welcome back to the third video of this playlist. In this video, we will be solving question number 12, the second question from section B of the most recent past paper of Physics Unit 2, which is the October 2024 Physics Unit 2 paper. So let's get started with question number 12 of this paper. So here the question says, copper wires are used to connect a length of nichrome wire to a cell as shown. Okay, we can see a nichrome wire is connected to a cell with the help of copper wires. The copper wires and the nichrome wire have the same diameter. They have the same diameter. Okay, copper has a greater number of conduction electrons per meter cubed than nichrome. Okay, so copper has a greater number of conduction electrons per meter. That is, it is called the N. The charge carrier density of copper, it is greater than the charge carrier density of nichrome. Okay. So the question is asking to explain how the average velocity of electrons in the copper wires compares with the average velocity of electrons in the nichrome wire. So basically, the question is asking to consider the drift velocity. Drift velocity is the overall velocity or overall movement of the electrons as current flows through the conductor, right? So we have to consider the drift velocity, and we know that the formula for drift velocity is related to this formula, I equals to n/v/q, right? So from where we can make v the subject. So if you make v the subject, you will get I over n/q. Okay, so we will consider this equation. Let's see how much mark is it. It is for 3 marks. Okay, so we know that v equals to, that is drift velocity, that's the average velocity. Drift velocity, it is equals to v, this is v equals to I over n/q. Okay, so since the nichrome wire and the copper wire are in series, so current through the series circuit, it's what? Constant. So we can consider I, current through both wires is constant as they are in series. Right? Okay, so I is same for both. Okay, I constant. Next, the charge carrier density for copper, it is greater. So charge carrier density for copper, it is greater, and they have the same cross sectional area. Q is constant. A is same because the cross sectional area is same for both wires. So A is constant, Q is constant. Q is the charge of electrons, right? So we can write here, since area of cross section of both wires are equal, so drift velocity v is inversely proportional to k over what? The area of cross section. Sorry, that charge carrier density, because A is constant, Q is constant, I is also constant. Therefore, drift velocity is inversely proportional to the charge carrier density. Therefore, which one will have greater drift velocity? Okay, so average velocity of electrons in the copper wire. Okay, so copper has greater number of conduction electrons. So N is greater for copper. Therefore, average velocity, that is drift velocity for copper wire, will be smaller. Therefore, average velocity of conduction electrons, right? Average velocity of electrons in copper wire will be smaller as n, that is charge carrier density of copper is greater than nichrome. Okay, so average velocity of electrons in copper will be smaller as n, that is the charge carrier density of copper, is greater than nichrome. So that's what we can write for question number 12 from this paper. Fine.